Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Amin bin Cik Adnan. The rest of the name is my team member, and the title of our mini project is lead and lag compositor. So for the introduction, in summary, the lead compositor is to enhance the transient response, while the lag compositor is to reduce the steady state error and improve stability. For the transfer function, this is our transfer function. K is 0.1, A 90, and B for 100, and C for 0, and D 8, and E is 10. For this is the question 2. The question wants to show the gain crossover frequency, phase crossover frequency, gain margin, difference margin from the side lag, and also for the bot plot technique. Right, this is the bot plot result from the side lag. As you can see, there is a reading which is at the magnitude plot. So it shows the gain margin. The gain margin is negative 8.277, and for the phase margin is we need to do the substitution from the 180 minus with 157.539, and we get the phase margin. This is the result from the side lag, and this also result from the side lag. PM is 22.37. The GCF gain crossover frequency is 1.111. This value is in hertz, so we need to change it to the radians, which is we need to multiply by 6.28. Same goes to the phase crossover frequency. Okay. Next is for the bot plot calculation. To do the bot plot technique, the transfer function is as shown in the figure. So we need to change the S to the S with J omega. Then we get the new transfer function, and we need to do the equation for amplitude plot. We need to arrange the equation properly. So the bottom one is the phase plot. Okay, this is the result from the bot plot technique. We can see the line from 21 dB and straight. Then it will that's for the amplitude plot. For the phase plot is the red line. The lines like a V. So that's all from me for question 1 and question 2.
So now for question 3. Question 3 asks use both lead compositor to further improve 10% of current phase margin of the response and show the final transfer function of the compositor and its phase and amplitude responses. Before that, we need to know what is lead compositor. Lead compositor is used to improve or increase the magnitude line at the phase margin. To doing that, first we need to do the calculation. What we need to do is we need to find the new phase margin, which is we need to multiply the original phase margin with 110%, and then we will get the new phase margin. Second, we need to find the alpha max. by doing the substitutional of the new phase margin with the original phase margin, we will get the value, and that value need to add with 15. After that, we will get the value of alpha max. After that, we need to find the value of alpha. We need to use the formula of alpha max equal to sin -1 alpha minus 1 over alpha plus 1. By doing the algebra, we will get the value of alpha, and then after we get the value of alpha and omega, we need to substitute that value into the formula of omega equal to 1 over tau power of root alpha. By doing the same method algebra, we will get the value of tau. After that, after we get all the value of tau and alpha, we need to substitute that into the GS equation. After substitute all the value, we will get the new equation for GS. For our equation, we get the new GS is equal to 1 plus 0.195s over 1 plus 0.106s. After that, by using the Scilab, we will need to do the Scilab using the given code, but we need to change the numerator C, denominator C, numerator and denominator with our value that we get from the calculation. After that, we will get the graph. As you can see, this is the lead compensator graph. As I mentioned, lead compensator used to improve transition response by 10% of the original transfer function. As you can see, at the magnitude graph, we see that the magnitude is equal to 2.56. If we can go back to the original magnitude, the original magnitude is 1.816. That shows that there is an increasing of magnitude in lead compensator.
Assalamualaikum, my name is Muhammad Ashraf and I will continue for the question 4. Okay, for the question 4, the question asks to use Bose lead compensator to further improve 10% of current phase margin of the response and show the final transfer function. Next, for the calculation, the first one, we need to find the PM current, which is 22.37. After that, we times with 110 over 100 times 22.37. After that, the PM need, we plus for the lead compensator, it must be 8 with 5, 24.61. So the answer is 29.61. Okay, for the frequency when phase, the answer we get is negative 180.39. After that, we change with into radian with times with 6.28. And for reduction, we times with 20 log and got a 1.268, and that's for the calculation. Okay, next, for the coding, we use a Scilab and put the answer for pulse and zero, and we get phase margin 28.199 and the gain margin 10.38. This is the graph for magnitude and phase. Okay, for the next question, question 5. Based on your finding question 3 and 4, which compensator that can be used to achieve 10% improvement of phase margin? please provide an explanation. Okay. For the answer, to achieve a 10% improvement in the phase margin, a lead compensator is typically used. The lead compensator introduces a phase lead in the frequency response, which can increase the phase margin of the system. On the other hand, a lag compensator introduces a phase lag, which tends to decrease the phase margin, while a lag compensator can be used to address other aspects of control system performance, such as reducing steady-state error. It is not the ideal choice for achieving the specific improvement in the phase margin. Therefore, if the goal is to achieve 10% improvement in the phase margin, a lead compensator would be the appropriate choice. That's all. Thank you.